So hello viewers and welcome back to this video. So in today's video what we are going to do is we are going to see that how we can simulate OSPF protocol on top of ns-3. And for me to make this video I took actually 2 weeks to get things set up, get things installed so that I can simulate OSPF protocol, because OSPF protocol cannot be directly simulated with ns-3, the latest version of ns-3 that what might we have been using right now. So in today's video we are going to see that how we can install ns-3 DCE, which is responsible or which will be core part if you want to simulate OSPF protocol with ns-3. And yeah, that's all about it, and we're going to see that how we can set up ns-3 DCE and simulate OSPF protocol on top of that. So yeah, let's get started with this. Now this is a page that I would like to mention when we start the explanation of the installation process, the requirements thing, the dependency that we want to install first. Now one thing you need to know is ns-3 doesn't provide the direct support to simulate OSPF and BGP, because let's say the people who contribute to this ns-3, they thought that let's say if we were to rewrite the OSPF protocol or BGP protocol, it's very large and it's not practically possible to write a whole protocol as ns-3 on top of ns-3 stack. So instead ns-3, they made ns-3 DCE, and DCE stands for direct code execution. Basically it allows us to simulate any kind of binaries or kernel space or network protocols on top of ns-3 stack. Or they also have an advanced simulation version where you can run all those protocols on top of Linux stack. So this whole binding, this whole stuff is configured or provided you with or in form of ns-3 DCE. So now this is the classical documentation that you can refer if you want to install ns-3 DCE and get started with it. But these are the steps that you might want to follow. Now, so this is the sentence that I want to focus on for this moment. So where they say DCE version 1.12 is tested on Ubuntu 20 only, which is pretty old, and DCE version 1.1 is only known to work for Ubuntu 16. So by now you might start questioning that this is very old, why we are still using it. This is very old, yeah, but this still works, and we don't have any other or any best option for us to simulate OSPF protocol with ns-3 stack. So this is this thing that we are going to go with, but you might have two options now. So I don't know whatever the current situation for you, how you simulate ns-3, but I assume that most of the people are using virtual machine. So if you have any latest version of ns-3 installed, you have two options to go forward. One is to downgrade all the installation, all the prerequisites, all the dependencies that you might require for ns-3 DCE, or the second version is to install Docker, which is mentioned over here. And I think most of the people should, or they must choose Docker option, because Docker is very easy. It provides us the separate virtual environment for us to install all the dependencies that might require for ns-3 DCE, and it's very easy because you can just download Docker images, Docker containers, and you can actually after that you have Ubuntu 20 Docker version of Ubuntu 20, you just execute this command sequentially, and at the end of executing all this command sequentially, you will have ns-3 DCE ready to be used. So yeah, let's get started with the installation process, and let me explain you a brief that how you can install those stuff. So yeah, as I said earlier, I'll assume that you all have a virtual machine installed, and you might be using ns-3 on top of your virtual machine only. So if you have virtual machine, so these are the commands, sequential, you can execute all these commands in sequence to have Docker installed on top of your virtual machine or Ubuntu, any version of Ubuntu that you might be using with. So basically update the system package, install dependencies. So these are dependencies that might be that will be used for installation of Docker, and most of the things might be installed by default. Then you add the Docker GPG keys, then you fetch the Docker repositories, and now if you use these commands, sudo apt install Docker, Docker CLI, Docker engine. So those are the things while by default will be referred as from over here, from Docker repositories, and the Docker will be installed. And you can verify this using this docker -f version. So these are the steps. I'll make sure to link all these steps in the description box, or I'll also pin this as in comment, so you might get all those things from there. Now let's get to talk about very tricky part, as I say. So yeah, don't get confused with this diagram. I just want to showcase that how I have configured all the things. So now if you have Mac machine like me with M1 chip, so you might feel very trouble while configuring all those things, because there is a one library or file which is sys/io.h. This is the file which uses the which is only configured to run on AMD processors, or you can say the processors which is having x86-64 base. And if you have like my M1 chips, the Mac machine with M1 chips, not the Intel based Macs, so you will be using these ARM processors. So that might collide with the dependencies, might the installation, and you might get certain errors while installing this stuff. But what you can do is, so this is the current configuration that I am using. So I have my M1, on top of I have my Mac OS, I have hypervisor and Docker engine on top of my OS, but I am not using Ubuntu 20 directly on top of my base Docker engine, because I want to keep all the NSA stuff separate. So that's why I'm installing everything on top of my guest OS, which is base Ubuntu 24. On top of Ubuntu 24 I have ns-3.44, the latest. I am not sure what is the latest. I am pretty sure it is not 3.44, it is 3.45, but I have 3.44 configured and running on top of Ubuntu 24. Now on top of Ubuntu 24 I have Docker engine, and on top of Docker engine I have been using this Ubuntu 20, the Docker container version, and this particular library. I don't know how to pronounce this name, but what this helps me is, this helps me to emulate x86-64, which means AMD versions of instruction set. So ns-3 DCE is installed on top of Ubuntu 20. That is a container, and that is using this particular container to translate all the CISC operation into RISC that can be easily understood by my base M1 processors. So yeah, that's the current installation process for me. You can also follow the same, or you can follow the different one. What you can do is you can basically install Docker, Ubuntu, and this too on top of base Docker engine if you want to simulate. But I just am using this. And yeah, again, if you have Intel processors such as i7, i9, so basically you will have this x86-64 processors, and you don't need to worry about this particular thing, this particular container, because you won't be bothered with this error, let sys.io is not supported on your ARM processor. So yeah, let's carry forward our discussion. Now I'm assuming that you have installed Docker successfully and you have all the things set up and ready to go. Now what you can do is, you can run, for a person like me who have M1 chips running on their Mac machines, they can register QEMU interrupts. Basically this thing that I told you, this is the library. I am not binfmt, I'm not able to pronounce it correctly, or I might be wrong while pronouncing it, so I'm just listing the commands over here. So all these commands, by the way, I'll make sure to ping in the comment section, so you can, or I'll make sure to add in the description box, so you don't worry about that. I'm just listing it out so that I can explain you better. Now once you have this register QEM interrupts for this emulation of x86-64, now you want to pull the Ubuntu 20 and make sure to add this ---- platform linux/amd64, so that it fetches the version which runs on this x86-64, because we don't want, because if we just write docker pull ubuntu 20.0, then it will match whatever the processor version that we have. So if we have something called ARM processors, so Ubuntu 20 will be installed for ARM machines. So you don't want that to happen. Now this command docker run, which basically runs the Docker container with the bash, the terminal. Now what I want to force you to do is this action to build and run, because what we can do is we can create our own Docker file which helps us to simulate or helps us to write the basic dependencies in the Docker file itself only. So while we perform this build only, what will happen is all the base dependencies that we might want for our virtual machine, Ubuntu 20 basically, that will be by default installed. So let's just see what is the what is the Docker file that I have been using. And you can also use the same again. And yeah, after that you just follow the installation step, all the commands that is listed over here, as in sequential commands. You can just give as in sequential manner. And yeah, one thing I would like to mention is this. So over here, when you install pip install request to any distro, before that you want to make sure that you have virtual environment running, because if you are not using those, the libraries might get installed but it won't be recognized by if you write Python 3. And I don't know, for some reason that's the error for me. You might also not face this, but it's good to create a virtual environment so that you might not conflict your package with the base version and with the version that is running on top of Docker container, on top of Docker engine basically, as in Docker container. So let's get to virtual machine, and let's do the hands-on. So again, this video might get long, but don't get confused a little bit. So what I did is, so let me just show you my setup. So this is my virtual machine that I'm running on top of my ARM machine, which is Ubuntu 24. Now inside the workspace you might have this bake folder where using that you might have installed any latest version of ns-3. So there I have created this folder which is called ns-3 DCE docker, and inside that I have certain files that I have copied from my container to my actual machine. And this is Docker file. Let me just show you cat Docker file. So yeah, so what this does is, this is using this, what this will tell is, so this will fetch Ubuntu 20 and this will run this dependencies. So these are certain dependencies that you might want to have when you start the installation. So yeah, these are the certain dependencies. And yeah, also this one, so bake clone, and to create workspace directory, and you will be directly having a bash session in this workspace directory. So these are the basic stuff that you might want to have when you start your container. So it's good to use this Docker file, and if you want this file, I'll also make sure to add this in the comment section or in the description box, so you just check for this file. Now remember those commands that I have showed you, these two commands. So you can just use these two commands sequentially and you will have this kind of terminal opened over here. Now once you have this terminal, what you can do is you will be probably having a cd. Let me just go for, okay, I don't know why this is okay. So you might have a workspace, you might have a bash session by default in this directory. Now what you want to do is you just go and copy paste all this command sequentially from this link. So you just copy this command, you just run it over here, you just copy the second command, you just run it here, let it finish, and you do all this stuff manually one by one. Now one thing to make sure is, as I told you, one thing to make sure is, if you are using this fourth command, before fourth command you use this, you go inside bake, you create a virtual environment, you source it, you activate that virtual environment, and from now you will execute every command inside your virtual machine, virtual environment. So after that, all the commands that are executed from bake directory, and every command is executed in the virtual environment. Now once you have this, what you will have inside bake is, so inside bake you will have, these are the files that you might have, and inside source, so let me just go inside source, and these are the things that you have. Now you will be installed with ns3.35, which is very old, which uses WAF, not even ns3. C executor, normal executor that we have, and this is the ns3 DCE. So let's go under ns3 DCE. So this is the main thing where we will be dealing with. So these are the files, these are the file structure that you might want to focus on. First thing is examples. This is the main folder where all the examples to configure, encode OSPF and BGP are written. And second thing is my script. All the sample examples that you might want to start with, they are mentioned in this folder. Now if you have this Visual Studio Code, you can just open a session on your container. So basically you can edit all the files using this container. And how I did is, so I can also show you that I have installed this extension which is called dev container. And after you install this dev container, what you want to do is, I'll just show you the docs first. So yeah, what I suggest is you just watch this documentation stuff that they have given for particular this dev containers, because it's really easy. What you can do is you can just use this attached to running container, and you can just open this session to container, and all the file system that are there on your container, any container, that you can use this, that you can view it from this virtual from this Visual Studio Code. Now remember the folder that I told you to visit, which is under this whatever, just a second. So yeah, where we want to go for the OSPF simulation, which is the script, the base script which reside under my script. So from the ns3 DCE, you want to go for my script, and under this ns3 DCE Quagga, and you want to go under example. So this is the particular path, and you want to open this file which is called DCE Quagga OSPF-d.cc. Now what this file does is, this file allows you to simulate OSPF protocol. So basically it provides you the ability to simulate OSPF protocol on top of ns3 stack and on top of Linux stack. So it has this command argument and nodes top 10 and net stack. Basically for the next net stack, you can specify whether you want to go with the Linux stack or the traditional ns3 stack. So ns3 stack means whatever the code that the code implementation internet stack that might have written for the ns3, so that you can choose the options. And there is a significant difference between ns3 stack and Linux stack that we will cover while we capture the packet capture or the PK file from this simulation. So the coding part is very similar. You can just observe, first we are creating nodes, then we are creating channel, then we are creating devices. Now based on the stack that we might have given, it will assign the IP addresses, and this particular part, Quagga helper, this basically allows us to enable the OSPF and certain debugging. So that is very typical, very major thing that you want to see. That is basically same for both of this stack. And yeah, I guess that's it. Then you are enabling all the packet captures, and you can just run and start and stop. So these are the basic configuration, and yeah, that is the major thing that I want to say. And you can just observe this file if you want to debug this in much more detail. Now what you want to do is, if you want to execute this file, you want to be there in the root folder of ns3 DCE. Now what you can do is, you can just run this command, which is called, basically it will simulate for the Linux stack. So let me just run this. Now this will basically compile all the files. This will basically simulate the Linux, the OSPF protocol on top of Linux stack. So, and at the end of the output, it will generate the PK files for all the nodes that are there on the simulation topology. Basically by default we have 2 nodes, so it will generate 2 PK files. So now let's wait for the simulation to be completed. So if you see, this has generated these 2 PK files on the base folder, which is ns3 DCE. So these 2 files is packet capture of these 2 nodes that we have simulated in our code. So now let's just observe these 2 files. And if you want to observe this file inside Wireshark, so basically I don't think you can directly observe inside your container. What you want to do is, you want to copy these 2 files inside your actual machine, inside your actual Ubuntu. So to do that, what you can do is, you can use this docker cp command. Let me just show that command to you. So yeah, This is the docker copy command. Basically what it will does is, so docker cp, which it will copy. So this is the name of my docker container, then the path of my file, and basically where I want to copy. So dot means I want to copy in current folder. I won't copy those files because I have already copied those files over here. Basically I can just show you the container name. So as you can see, this is my container name and it is still running. Now what I want to do is, so I'll just list the files. So yeah, these are the files that I have copied, and these are the packet captures that we have captured while the Linux stack was used. Now this inside this folder ns-3 stack, we have this similar to files, two packet capture files, but the difference is this packet capture files are captured for the configuration where we didn't use the Linux stack, instead we use the ns-3 stack. So now let's observe the packet captures and let's see what's the difference. So yeah, so these are the two packet capture file that I have kept open. So first one, So the first one that we have opened over here, that is packet capture file, which is captured for the ns-3 stack. Now if you see by looking at over here, so this is the file that has been executed for the Linux stack. So Linux stack, you can observably just point the difference that you won't see ICMP or IGMP packets over here on the packet capture file, which is captured for the ns-3 stack, because in ns-3 stack we don't care for this IGMP packets, because we don't send those packets, but we still send these packets of OSPF, hello OSPF, and every base protocol is OSPF, so we send all those packets that might OSPF sent, but we don't follow or we don't send this IGMP grouping protocol messages. So that's the main difference that I want to show. And if you want to observe any of the other packet, you can just click on it and you can just see how the OSPF packets are captured, how OSPF packets are structured. So all those packets you can observe it over here. So it might not differ, or it must not differ in both of this stack. It's just that you might not see this ICMP or IGMP protocols over here. So yeah, with this I hope you got the idea of how you can install ns-3 DCE and how you can simulate OSPF protocol on top of ns-3. And yeah, if you have any of the questions with this video, I hope that you don't have any questions, but if you still have any questions, I'll be happy to answer all of those. Make sure to add any of the question, any of the doubt that you might have in the comment section, or if there are any errors that you might facing in the installation step, let me just know. I'll make a video to resolve all those errors. And yeah, with this video I guess that's it. We'll meet in the next one. Till then, keep learning and keep exploring.